Have you ever wondered if time travel could be a reality? Picture this. You hop into a sleek silver machine, dial in a date from the past, and in a flash of light, you're there. It sounds like a scene straight out of a sci-fi movie. Time travel has been a staple of science fiction and popular culture for decades. From H.G. Wells' The Time Machine to the Back to the Future trilogy, the idea of hopping between different eras has sparked our imagination and curiosity. It's a concept so wild and so captivating that it's hard not to wonder if it could ever be more than just exaggerated storytelling. But what does science have to say about all of this? Could time travel ever be a reality, or is it forever confined to the realm of fiction? Well, the answer isn't as straightforward as you might think. Science, specifically the realm of theoretical physics, has indeed dabbled in the concept of time travel. The most famous theory that touches on this is Albert Einstein's theory of relativity. Einstein's theory transformed our understanding of space and time, suggesting that they are interwoven into a single continuum known as space-time. It's a mind-boggling idea that has far-reaching implications, one of which is the possibility of time travel. According to this theory, if one could manipulate space-time in a certain way, it could create a sort of bridge, a shortcut through time. However, this is far from a simple task. Manipulating space-time would require immense amounts of energy and advanced technology that we currently do not possess. Plus, there are numerous paradoxes and dilemmas that come with the idea of time travel, adding further complexity to an already intricate subject. So, is time travel just a figment of our imagination, or could it be grounded in reality? It's a question that continues to captivate us, and while we might not have a definitive answer yet, the journey to uncovering the truth is just as fascinating. What if I told you that ripples in space-time could hold the key to time travel? Now that's a loaded question, isn't it? But to unpack it, we first need to understand what these ripples, or gravity waves, actually are. Gravity waves are distortions in the fabric of space and time. Imagine a trampoline. If you drop a bowling ball onto it, the trampoline will distort under the weight. This distortion is similar to how gravity works in space. When a massive object, like a planet or a star, exists in space, it warps the space around it. This warping, or distortion, is what we experience as gravity. Albert Einstein predicted the existence of these waves over a century ago in his revolutionary theory of general relativity. But it wasn't until the 21st century, in 2016 specifically, that we humans were able to confirm their existence. The Laser Interferometer Gravitational Wave Observatory, or LIGO, detected the faint whispers of gravity waves resulting from a collision between two black holes a billion light-years away. The discovery of gravity waves was a massive achievement in the world of physics. It confirmed Einstein's predictions and opened up a new way of observing the universe. Just like light waves let us see the universe, gravity waves let us feel the universe. They give us a new way to study cosmic events that would otherwise be invisible. Gravity waves are also crucial to our understanding of the early universe. They can potentially provide us with information about the Big Bang and the evolution of the universe over billions of years. This is because, unlike light and other electromagnetic waves, gravity waves are not easily blocked or scattered. They can pass through just about anything, giving us a clear sound of the universe's history. Gravity waves are not just waves, they are ripples in the fabric of reality itself. They are the key to unlocking the mysteries of the universe, and perhaps, just perhaps, they may even hold the key to time travel. But that, dear listener, is a topic for another scene. Ever heard of a clock ticking slower in space than on Earth? Sounds like something out of a sci-fi movie, right? But in the world of physics, this is a reality, and it's all thanks to a man named Albert Einstein and his theory of relativity. In 1905, Einstein introduced his special theory of relativity, which fundamentally changed our understanding of space and time. According to this theory, the laws of physics are the same for all observers, regardless of their state of motion. But here's the kicker. Time and space are not separate entities as we usually perceive them, but are interwoven into a four-dimensional fabric known as space-time. Now let's dive into the concept of time dilation. In simple terms, it's the difference in the elapsed time measured by two observers due to a relative velocity between them or to a difference in gravitational potential between their locations. When Einstein extended his theory to include gravity in 1916, he found that massive objects cause this space-time fabric to curve, creating what we call gravity. So how does gravity affect time? Well, think of a rubber sheet stretched tight. If you place a heavy ball on it, the sheet dips. The heavier the ball, the deeper the dip. Similarly, in the universe, the heavier an object, the more it warps space-time and the slower time passes near it. This is why a clock in space ticks slower than one on Earth. The Earth's gravity is literally slowing down time. This phenomenon, known as gravitational time dilation, is a real effect. It's been tested and confirmed through countless experiments, from atomic clocks on jet planes to GPS satellites orbiting Earth. So next time you're running late, don't just blame the traffic. Remember, in the realm of gravity, time is not a constant. Could a shortcut through space-time be our ticket to time travel? That's a question that has captured the imagination of physicists and sci-fi enthusiasts alike. Let's talk about wormholes, the theoretical tunnels that might just be the key to this fascinating possibility. Wormholes are bridges in the fabric of space and time. Now imagine holding a piece of paper representing our universe. If you fold it in half and poke a hole through it, you've created a direct path between two distant points. This is a simplistic way of visualizing a wormhole, a shortcut through space and time. According to Einstein's theory of general relativity, wormholes could exist within the universe's fabric. They're predicted to occur when colossal amounts of energy distort space-time, creating a tunnel connecting two separate points. But remember, this is still theoretical. Despite the best efforts of scientists, we've yet to find concrete evidence of wormholes. How could wormholes enable time travel? It all comes down to their unique structure. If one end of a wormhole is anchored in the present while the other is flung at near light speeds, then brought back, the time at the fast-moving end would slow down relative to the stationary one due to time dilation. This would create a bridge not just across space but also across time, enabling travel into the past or future. However, it's not all rosy. Theoretical physicists warn that wormholes might be highly unstable, collapsing the moment anything tries to pass through. Some propose the use of exotic matter with negative energy to keep them open, but such matter is, well, purely hypothetical at this point. So, while the concept of wormholes and time travel is fascinating, we're still a long way from turning science fiction into science fact. Despite the challenges, the pursuit of knowledge continues. After all, it's the possibility of the unknown that drives us forward. Wormholes could theoretically turn the dream of time travel into reality. But for now, they remain a captivating mystery in our exploration of the cosmos. How do gravity waves tie into the concept of time travel? Well, it's a fascinating journey of science that connects the two. Gravity waves, or gravitational waves, are ripples in the fabric of space-time caused by accelerating masses. Imagine a stone being thrown into a pond. The stone disturbs the water, causing ripples or waves to spread out from the point of impact. In a similar way, when a mass accelerates, it causes disturbances in space-time, resulting in gravitational waves. Now, let's bring in the concept of time travel. Time travel, at its core, is moving between different points in time, just like we move in space. But how do we move in time? The key lies in the very fabric of the universe, space-time. Gravity waves are distortions in space-time, so if we could somehow harness these waves, we could theoretically manipulate space-time. And if we can manipulate space-time, we could potentially create a pathway through time. A time machine, if you will. But before we get too excited, let's be clear that this is all theoretical. We're in the initial stages of understanding gravity waves. Detecting them was only possible in the last decade, and manipulating them is a whole different challenge. Yet the idea itself is not entirely far-fetched. Theoretical physicists suggest that advanced civilizations could potentially harness the power of gravity waves to travel through time, but that's a topic for a different day. The fascinating connection between gravity waves and time travel is a testament to the boundless potential of human imagination and scientific exploration. As we delve deeper into these mysteries, who knows what we might discover? Gravity waves might just be our key to unlocking the mysteries of time travel. Could we ever harness the power of gravity waves to travel through time? This question sparks a whirlwind of captivating thoughts and ideas. But before we get too carried away, let's ground ourselves in the reality of our current scientific understanding. As it stands, the concept of time travel, as thrilling as it is, presents an array of formidable challenges. For starters, the energy requirements for such a venture are astronomical. To warp the fabric of space-time in a way that allows time travel, we're talking about energy levels that dwarf anything currently available to us. Then there's the issue of stability. Even if we could create a wormhole, a shortcut through space-time, maintaining its structure long enough for anything to travel through it is a hurdle we've yet to overcome. Not to mention the dangers of intense gravitational forces that could rip apart anything that dares to venture through. But let's not get too disheartened. Every great scientific breakthrough was once a perplexing challenge. So, what about the possibilities? If we could learn to control gravity waves, we might just find the key to unlocking time travel. Imagine, if you will, a world where we could manipulate these ripples in space-time, bending it to our will. We might be able to create pathways to the past or future, a prospect as exciting as it is overwhelming. And the implications? They are nothing short of revolutionary. We could witness history firsthand or see what lies in store for us in the distant future. We could unravel the mysteries of the universe in ways we've never thought possible. Sure, these ideas might sound like they're straight out of a science fiction novel. And yes, we're far from turning this dream into reality, but remember, many of the technologies we take for granted today were once the stuff of sci-fi. While time travel remains a dream for now, who knows what the future might hold? So, are we any closer to stepping into a time machine? The answer will lie in our ability to absorb and adopt these theoretical principles. We've embarked on a fascinating exploration today, delving into the intricate connection between time travel and gravity waves. This complex relationship is rooted in our understanding of the universe and the laws that govern it. Let's briefly revisit our journey. We started with the enigma of time travel, a concept that has captivated our minds for centuries. Next, we dove into the mystery of gravity waves. These ripples in the fabric of space-time, predicted by Einstein himself, have only recently been confirmed. They're not just theoretical anymore, they're real, and they're opening new doors for scientific discovery. We then examined the theory of relativity and time dilation, understanding how gravity can bend not just space but time itself. This understanding bridges the gap between space and time, providing a theoretical foundation for time travel. In the context of gravity waves and time travel, we've explored how these cosmic ripples might offer a pathway to traverse time. The potential implications are staggering, with possibilities for future research and exploration that could redefine our understanding of reality. However, we must also remember the challenges. The energy required, the technological hurdles, the sheer scale of the task. These are not minor obstacles. They remind us that while time travel remains within the realm of theory, it is not yet within our grasp. Yet, the pursuit of knowledge is rarely straightforward. Each discovery, each breakthrough, brings us one step closer to understanding the fundamental truths of our universe. As we continue to push the boundaries of science, we are constantly redefining what is possible. As we continue to unravel the mysteries of the universe, one thing is certain: the journey is just as exciting as the destination.